Welcome back to part 3 of our Spaceship in Unity tutorial series. In this one, we'll discuss how to build a weapon system with 2 modes. There's going to be the projectile weapon, where it shoots, physical projectiles in space, and then there's a raycast weapon, which will, in our case, shoot a continuous laser. Raycast weapons are also how you get hit scan weapons if you've ever played shooters, and you know what that is. So the way this is going to work, the player is going to be able to fire by holding an input, and they're going to be able to toggle between the 2 weapon modes. Let's just go over our core behavior. We're going to have the projectile weapon, which is going to alternate between those left and right fire points we made last time. We're going to pull the projectiles from a pool, so we're not instantiating and destroying them every time. We are using the same bullets over and over and over again. This is a lot more performant, a lot less wasteful. Each projectile is going to handle its own behavior for moving forward, detecting if it has hit something, and then spawning some VFX, causing damage, all that. The raycast weapon, you might have guessed, is going to use a raycast, which shoots this invisible laser beam through space. And it's going to detect things. It's going to deal damage continuously over time. The visuals are going to match that raycast. So we're going to have a laser beam. We're going to use a line renderer to create that laser beam. We're going to have an impact effect at the point where the laser collides with something. And we'll have sound effects for when the laser starts, a loop for as the laser is just going, and an end sound for when the laser ends. So it doesn't just sound like it cuts off. So here's the basic flow of things. In our update method, where something happens every frame, we're going to read the fire input. And then we're going to say, if projectile weapon, then inside of that, if firing and fire rate is ready, then fire projectile. And we'll stop the laser if the laser is active. Otherwise, if we're using our raycast weapon, if we're firing, if we just started, there's going to be some nested if statements here. Then we'll start our laser effects, then we'll fire our laser. Otherwise, if we were firing, then we're going to stop our laser effects. Then on toggle weapon, we're going to switch which weapon we're using, and if there were laser effects going, we're going to stop those. So let's look at what our system responsibilities are going to be. We need to keep things modular. So inside a weapon firing script, we're going to have detection of the input, weapon switching, our firing logic, the laser, VFX, SFX, control. And then in a projectile script, it's going to control its own movement, collision, damage, impact effect, returning itself to the pool. Then we're going to have another script, which we'll call simple pool, and that's going to handle the actual pooling of things. It's going to reuse objects. Then we're going to have a simple health script just so we can actually detect damage being taken and destroy things when they run out of health. Key mechanics here, weapon switching, we're going to use an enum. Projectile weapons, moving through space. Raycast weapon, using a raycast to make a laser beam. Single state variables to multiple booleans, easy to extend later. Projectile firing, we're doing alternating barrels using left or right fire points. We're going to always flip for the next shot. Pooling is going to be very important for that. We'll have a fire rate so that we limit how much we're shooting. So when we want something like rapid fire, you would think, oh, just do it every frame, shoot a bullet, and alternate. That's going to be insanely fast. Maybe that's what you want, but probably not. So we're going to use a fire rate to limit that. For actually moving the projectiles, we're going to do the classic position plus equals forward times speed times delta time. And in case the projectile doesn't hit anything, we want to give it a lifetime. So we're going to say if time is greater than spawn time plus lifetime, then return it to the pool. If we've shot something into the void and it never hit anything, don't just let it run out there forever. Have it disappear and return to the pool. In terms of collision, it's actually pretty straightforward. We're just going to check if the thing we've collided with has our simple health component, and if it does, we'll apply damage to it, we'll spawn an impact, and then we'll return the projectile to the pool. Now the raycast weapon is actually per frame. Per frame, while firing raycast forward, if we hit something, deal damage, update the impact VFX to be at that place where we're detecting a hit, and update the beam, the line render, so it's also the exact length in terms of the distance between where you're firing from and the thing you're hitting. And then in order to deal damage over time properly, we're going to say damage this frame equals damage per second times delta time. This is going to keep the damage consistent across all frame rates. For actually visualizing the beam, it works like this. The raycast is the logic of things. The line renderer and the VFX are the visuals. The starting point for our line renderer is always going to be our little fire point, and the end is going to be the hit point of our raycast, or the max range if we set a limit on how far our raycast can detect things. And for the laser feedback, it's a little more nuanced than the projectile feedback. We want the impact effect to move to wherever the hit point is. Then we want to align it to the surface normal. We need to enable it or disable it. For the audio, for this to not sound really janky and choppy, we want to have a start, an intro sound. We've turned our laser on, a kind of a thing. And then for the continuous laser beam, once it's firing, it should be looping, right? It's just a looping something kind of a sound. And then when you let go, you don't want to have that audio loop just stop. So we play one more final sound effect towards the end. That's just a little wind down sound. So the whole thing might be like, does that make sense? Then we need to track the previous frame state. If we were not firing and now we are, we need to start. If we were firing and now we're not, we need to stop. We have to check that every frame because it's a loop. And then breaking down our simple health is going to be just that. We're going to have a take damage method. We'll say health minus equals damage. If health is less than or equal to 0, destroy it. I'm not going into too much depth here with that. Both weapon types will access that health script and see, first of all, does the thing I'm hitting have one of these scripts? And if it does, deal damage the way that I deal damage. The system is pretty straightforward conceptually. It may be a bit challenging, though, to actually execute it. But here's what it demonstrates. We have input-driven weapon logic. We have a clean state management with the enum. We have projectile weapons versus sort of hit scan design. We have object pooling. We have fire rate control, frame rate independence, continuous damage, damage over time. Separating our logic from our visuals, that's important. Modular, maintainable structure. This is easy to extend later. That's a lot to cram into these couple of small scripts. So just like before, you should have everything you need to get started making your own script. So give that a shot. A week from today, I'll be releasing the next video, at which point you can compare your solutions with mine or copy me if you got stuck and you aren't sure why. If you find yourself struggling, just know that you're not alone. As I said before, if you watched this video and felt it was a bit too advanced for your current level, I highly recommend checking out the Math of Video Games series, as that one is really meant for beginners. And it'll help you get established with some of the more fundamentals that you need to understand to be able to do something like this. Thanks so much for watching, and I'll see you in the next one.